program, Professor George Schatz is the Charles and Emma Morrison Professor of Chemistry at Northwestern University. George received his undergraduate degree in chemistry at Clarkson and a PhD at Caltech. He was a postdoc at MIT, and he's been at Northwestern since 1976. George is a theoretician. He studies the optical, structural, and thermal properties of nanomaterials, including plasmonics and plasmonic metamaterials, DNA and peptide nanostructures, and carbon-based materials. George has contributed, and his group have contributed theories of dynamical processes, including gas phase and gas surface reactions, energy transfer processes, transport phenomena, and photochemistry. George has, he knows a lot about publishing. He's published 4 books and over 1,000 papers. He's a member of the National Academy of Sciences and the AAAS Fellow. He's received many awards, including the Debye and Langmuir Awards of the ACS, the Burke and Boyce Rahman Award of the RSC. He's a fellow of the APS, the Royal Society of Chemistry, the ACS, and as I said, the AAAS. But I think, perhaps most pertinent to today's talk is George is a longtime senior, he was a longtime senior editor of the Journal of Physical Chemistry. He became the editor-in-chief in 2005. The journal previously having been split into JPCA and JPCB, George initiated the spinoff of the third journal, JPCC, focusing on nanotechnology and molecular electronics. So he has tremendous insight into the process of academic publishing. So we're excited to hear from you, George. You're a center member in your capacity as an expert in the field of academic publishing. George.
Hey, thanks very much. And I hope everybody can see the slide that I have here, which is just the title of the talk. Okay, good. All right. So first of all, let me thank Eric for including me in the program. I'm gonna, this is one of the few opportunities that at least I get to talk about topics that are not just specific scientific topics, but rather the larger story. And so, of course, I'm happy to do that. And I think it's something where this is, I'm going to give the talk from the perspective mostly of say, graduate students, postdocs, maybe undergraduates who are actively involved in research in the center or maybe in other types of research. And ultimately do the research projects, and you're going to start thinking about, well, I want to publish my paper on this topic. What do I do? What's the process? How should I think about this? What journal should I be thinking about? And just what's the mechanics of writing the paper, of submitting the paper, and ultimately getting it published. So I'm, this is stuff that we all, you get to my age and you've all lived other lives, and so I lived this other life in the publications business for a long time, and so something that I'm happy to talk about. All right, let's see if I can get this to go. Yeah, okay, so I'll begin by just saying, okay, what was my other life? Okay, so I was the editor-in-chief of Journal of Physical Chemistry for 15 years, and it's actually 4 different journals, ABC and letters, and so we'll see a little pieces of that story. In the end, I'm kind of trying to talk about publications in general, so I don't necessarily I'm talking about JPhys Chem, but ultimately I know more about that journal than about anything else. The other aspect to realize is JPhys Chem is a part of ACS publications, American Chemical Society publications. They now have about 50 journals total. Okay, so it's a huge operation overall, and a lot of what I'm going to be saying are things that relate to the operation overall. If you have papers that relate to some of the topics associated with the CSSM Center, you might publish them in JPhys Chem, but you might publish them in other journals. There's always this question about what is the right journal for publishing your papers. The Journal of Physical Chemistry is a kind of a big old monster journal. And it was started in 1896. It has actually an interesting history that I have a different talk that I sometimes have to give that relates to that topic. It turns out that in 2019, which was my last year's editor, we published about 6,000 papers, and 60,000 pages roughly. Since the beginning, we've published 175,000 papers. So it's just this monster operation. And that's in the end, I always say, if you think about market share, we have the market share. That's not the problem. It turns out, though, in publications industry nowadays, sometimes you're punished for having the market share. But in any event, that's the deal. There's 37 editorial offices scattered around the world. We cover all areas of physical chemistry. And then here are the impact factors. I'll talk about those in a few minutes. And highest total citations in the field of physical chemistry. I mean, there's some other large journals in this area, but JPhysChem is the big one. And so therefore, when I talk about JPhysChem, I often talk about the empire. Okay, it's really these 4 different journals that got split apart in various stages, but it's collectively managed as one journal. And then there are many different kinds of articles you can publish in them. Of course, normally we're just thinking about regular papers, okay? And so there's, for A, B, and C, that's regular papers, and then letters, you publish letters. But then in addition, there's other kinds of publications that are done. There's something called feature articles or perspective articles that have to do with more like review-related material, sometimes about your own stuff, sometimes about the field in general. There's something called viewpoints, which are more, your opinions, or it's kind of more editorial-related material. In JPhysChem letters, there's also something called spotlights and limelights, which are written by the editors and summarizing content of many papers. There's something called live slides, which is where you're basically publishing a slideshow about your research. There's different kinds of issue types. Okay, the regular ones are where just the issue contains a bunch of scientific papers. There's special issues in which a lot of times that's invited content, where the editors go around and invite people that do research in a given area to talk about, to present papers in that area. Or sometimes it's a Festschrift issue in which you identify some person and you want to publish papers related to that person. There's something called virtual issues, which are really just web pages that collect the content of many different papers that have been published as regular papers in the journal. There's virtual special issues, okay, where it's these invited content type things. And we also have Facebook pages and Twitter functions, okay, so you can become a friend in Facebook, all that kind of stuff. There's something called ACS Actual, which is a blog that talks about all of ACS publications, but would include material related to physical chemistry. There's something called Editor's Choice, which is where one paper every day is selected out of all of ACS publications. There's a committee that makes that decision as being designated for open access. So it's free open access for that paper. So if you get selected for Editor's Choice, that's great, okay, but there's not that many papers that are selected for Editor's Choice. The journal impact factor, okay, so you probably heard a lot about journal impact factor. It turns out that actually initially in 1975, I would say for maybe the first 20 or 25 years of existence, it was largely ignored. And then more recently, it's just become, a bigger and bigger deal, okay? And, it's like nowadays, you can certainly talk to a lot of people where it's the only thing that dictates which journal that you want to publish in. You can decide the wisdom of that. How it's defined, it refers to the yearly average number of citations that the journal receives concerning articles that are published in the previous 2 years of a given journal. Okay, so what that means then is the 2019 journal impact factors that were recently published in June, they refer to papers that were published in 2017 or 2018. Okay, so if you think about that for a second, that means that a paper that was published at the end of 2018 gets 1 year to be cited, okay, all of 2019, to determine its contribution to the journal impact factor. Okay, so 1 year, okay? So it's a very short term measure of publications. Okay, a journal impact factor is a number that's published by a company called Clarivate Analytics. They're also the company that owns Scholar One. Scholar One is the company that you deal with mostly for submitting journals and papers to journals with ACS publications and for many other publishers. So in the end, that's just a separate function. Journal impact factor, of course, you might say, well, anybody should be able to calculate the impact factor of a journal by just looking up all the citations, say in Web of Science or Google, and you should be able to get that number and then figure out what the journal impact factor is. Turns out, actually, the citations that Clarivate Analytics uses to calculate the journal impact factor are secret. Okay, you don't know where they get that information from. It's been highly criticized because of the lack of transparency associated with that, but nevertheless, the publications industry worships the journal impact factor, and therefore you just have to live with whatever it leads to. So I'm showing you journal impact factors of a bunch of different journals. I've included a bunch of ACS journals. So ACS Energy Letters was 19 in 2019, and JPC Letters was 6.7. There's a bunch of different journals. Many of us are interested in publishing in JACS. That was 14.6. Angevante 12.9. These two journals compete with each other, so they're constantly looking at each other's impact factors. So I won't go through. Actually, I'll talk about a couple of these. There's one here, Nature Energy 46. Gosh, how high a number can you get? Okay, but it turns out actually the highest impact factor on this chart is chemical reviews at 52. So in the end, you want to publish in a high impact factor journal. It's very simple. Write a review article for chemical reviews. You did it. Okay, done. Okay, so it's in some respects the journal impact factor is not hard to publish in a high impact factor journals. Chemical reviews is the obvious one in this particular chart. Okay, so then over on the right are some more what I call mainstream journals. Remember I said about JPhysChem having all the market share associated with physical chemistry. Well, okay, the bad news on that is you get low journal impact factors as a result of that. And it doesn't matter whether it's JPhysChem, you might look at another journal. JCP is a competing journal, same deal. PCCP, same deal. Okay, it doesn't really matter. If you control all the market share, then you're unfortunately going to be stuck with low impact factors. All these journals over here with high impact factors, except the review articles, are trying to basically sift off the highest papers, highest impact factor papers. And so that's basically their mantra. So anyways, and also Science and Nature, here they are, 41 and 42. It's something where, those are, they've become, or whatever, the darlings of the impact factor industry. So you might say to yourself, okay, this is it. This is what the publication industry worships. It must have some absolute goodness that is, why is that? Well, so let me show you some other numbers. Okay, darn, let's see if I can get this thing back. Okay, so there's something called the H5 index. Okay, this is published by Google Scholar. Okay, so it's a competing measure. It's just another set of numbers. Okay, that you can look at. H5 means that it's a 5-year impact factor, so it has to do with citations to papers over a 5-year period. You could argue maybe that makes more sense, but I don't know. If you look on their list, so they list simply the top 100 journals in all areas of science. The top journal, Nature, this year, and then you see Science just a little bit below. So in that respect, Nature and Science show up in the top slots there, similarly to what you got in some of the in the journal impact factor. You see chemical reviews also very much at the top, so that's okay. JAX shows up very high in this particular list. Okay, PNAS. Okay, these are well-defined journals. If you jump down, eventually number 85 on the list is Nature Energy. Okay, not much different than Journal Physical Chemistry Letters at number 92 on the list. You might remember that in the Journal Impact Factor, Nature Energy was up in the mid-40s. Okay, Journal Physical Chemistry was only 6.5. Okay, so this is where you get a huge difference between the Journal Impact Factor number and the H5 index number. Okay, so you have to decide to yourself, okay, when these numbers are so different, what does either of them mean? And then it turns out in the H5 index, there's actually broken up in categories. Here's the mathematics and physics category, which doesn't even mention the word chemistry. And then under that is spectroscopy and molecular physics. And if you look under those, JPhysChem A is number 4 on that list. So even though it's not a physics or math journal, and spectroscopy is only a little piece of JPhysChem A, it turns out that it shows up as number 4 on this list. Okay, and then if you look under chemical and material sciences, under nanotechnology, you discover JPhysChem C is number 8 on that list. And a number of ACS journals are also rated high on that. So in the end, this is another way of understanding, the impact of journals based on citation information. It still is only a 5-year measure. There's all sorts of papers that I can find for you where they got hardly any citations in the first 5 years after publications. But eventually that topic took off, and now they have thousands and thousands of citations, but those aren't counted to any of these lists. All right, so now what I'd like to do is to talk a little bit about scientific publications. Just let me begin by pointing out that, of course, this is all about peer review. And what that means is that as the author of a paper, you're going to submit the paper to a journal, and then there's editors of that journal, and they will then send it to reviewers, or they might send it to reviewers, and then those reviewers will give their opinions about the papers, and then ultimately back to the editors. The editors will look at those opinions of the papers. They might reject the paper, or they might tell the author you have to revise that paper. Ultimately, the editors will make some decision about whether the paper should be published or not. Okay, so in the end, that's the process. Okay, and so there's people involved in each of these little categories. The authors of the paper, of course, they can't review their own paper, but they often are reviewers of other papers on similar topics. Okay, so that's the deal. There's a little bit of a question about who are the editors involved in this. So it turns out that for ACS journals, the editors are scientists, and so therefore they are often the authors and the reviewers. Okay, so in ACS journals, the editors are the authors and the reviewers. Okay. But for other journals, that's not necessarily the case. Okay, for example, in all the nature journals, the editors are professional editors. Okay, and so they are people that aren't writing the papers themselves, or they're not reviewers of the papers. So it's a little different model. So for each each journal, you'll probably want to think about just who's looking at your paper as an editor, and what are the consequences of that. All right. So that's one point. Now, so then the question is, well, what is the publications business all about? What is scientific publication? Of course, there's some general statements you can make, like the object of research is to extend human knowledge beyond what is already known. So the individual's knowledge enters the domain of science only after it's been presented to others in a fashion that they can independently judge and judge its validity. So that's the peer review part of the process. Okay, there's some statements you can find by people like George Whitesides, is a well-known chemist at Harvard. He made a statement in which he said, if your research does not generate papers, it might just as well not have been done. Okay, so that's a pretty bold statement, but nevertheless, in some respects, it's true. Okay, if you did research and you didn't publish that result, then does anybody know that it ever took place? Sometimes you do. Okay, there's a lot of great unpublished stuff, but nevertheless, it's something to think about. And then there's a guy named Prashant Kamat, who's the editor of ACS Energy Letters. Actually, he worked with me for many years at JFIS Chem. He says, if your paper does not generate citations, it might just as well not have been done. The point he was making here is that you can publish your paper, but if nobody cites it, then did anybody care? Okay, and you might, so there's a number that people actually keep track of, which is the number of papers published in various journals that generate no citations ever. Okay, and for most journals, that number is on the order of a few percent. You might say, well, if I publish my paper in Science or Nature, is it possible that it'll get no citations? And the answer is yes. Okay, there's a few of these papers published every year that get no citations. And so you could say, oh my gosh, okay, wasn't my paper a great paper because it got published in Science or Nature? Well, not great enough so that somebody wanted to cite it. So that's kind of an interesting phenomenon. All right, well, okay, so it used to be that it was publish or perish. More recently, it was published in high impact journals or perish. I think that's where the journal impact factor business really took off. And then, of course, maybe now it's more like publish frequently in high impact journals and maybe you won't perish. Okay, so in the end, I think, that's one of the issues of why the journal impact factor business all just took off over the years. Okay, so, okay, when are we ready to write a paper, okay, about something or write a manuscript about something? So a key question is, do my data tell a story, or are they just merely pieces of information? Okay, so that's the thing I often talk to my graduate students about. It's like, okay, do you have a story that you can tell based on the results that you've generated? And of course, do the results move the state of the knowledge of the field forward? I mean, sometimes you just generate a bunch of results, but they're not really something that really pushes the knowledge, and so that's the problem. And is it relevant to others? Maybe you've got a great story to tell, but nobody, besides yourself, would ever care. So that's another issue. Of course, in the end, there's a process you might imagine going through with respect to just like getting ready with data and structuring the paper and the understanding with respect to the journal that you're going to submit to, what's the scope of that journal, and then going through the submission process itself. And then revision, proof stage, things like that. There's actually a paper that I wrote with Prashant Kamat, 2013, has this title, How to Make Your Next Paper Scientifically Effective. And you'll see in a second some information from this paper, and also it turns out that this was a part of 20 papers that we orchestrated on the general topic of scientific publications, and I'm going to mention some of the information about that project in a second. All right, so this was in the paper that I just cited. And it just has to do with gathering together the data and organizing the results and consolidating data plots, things like that, discussing the outline with your advisor, and ultimately just how to generate a paper. This is a little bit of a flow chart for generating the paper. I won't go into details. And then there's discussions about just how do you compose the title of a paper. Okay, so simple, attractive, accurately reflects the investigations. Turns out a lot of journals won't even let you use the word novel in the title. Okay, that's pretty common, so you have to be aware, even though you think it's novel, that's up to the opinion of the reader, so they won't let you use the word novel. And then there's a question about which of these two titles are the most effective, or going to make you want to read that paper. So here's one: study of SIRS chemical enhancement factors using buffer layer assisted growth of metal nanoparticles on self-assembled monolayers. Oh my gosh, this is pretty complicated. But then how about this one? Signal on detection of DNA whole transfer at the single molecule level. I think I'd read the second paper actually first, even though the first paper is out of topic that I care about. But in any event, that's the sort of issues you have to think about. in the abstract, you want to keep it short and effective, and include the major findings in a style that the readership can understand. Okay, so this is just an example of an abstract for like a letters type paper. So it says, okay, one sentence providing background to the problem, and then two or three sentences that summarize the major finding. You see those in the middle, and then a concluding sentence that highlights the significance of the study. Okay, so this is a pretty short abstract, but it's crucial. Okay, especially if you have a letters type paper, you want to be able to write an abstract like this. Okay, so things to think about. Okay, so and then there's the main body of the paper itself. I'm not going to go through all the details on this. I think many of you probably know the overall organization. Starting with the introduction, and in the introduction, you needed to point out the issues that are being addressed in the present work. You'd be amazed that people will write introductions that doesn't have that, and you want to have 2 to 3 paragraphs to describe previous work. Sometimes people don't do that. The experimental section, or materials and methods and so on, sometimes that's put at the end of the paper, sometimes not, but anyways, obviously you need to provide all that information. You need to then results and discussion, things like that. You want to avoid excessive presentation of data or results without any discussion. In other words, it's not just simply a list of figures or tables or with no discussion. It's crucial that every figure has some meaningful discussion, actually contributes to the overall point of the paper. Okay, so anyway, so these are just some general discussions about how to do this. The conclusion section, of course, should include the major findings that are in the paper. Again, you'd be amazing. People submit papers, there's no conclusion. They just want to present the results and no conclusion. So anyways, don't rewrite the abstract. I won't say anything about acknowledgments. The reference styles, okay, so you just have to look up the reference style for the journals you're submitting to and make sure you match that. That's important. There can also be supporting information. In fact, supporting information is often a crucial part of the paper. It's where you get to present the methods, the analysis, the blank experiments, additional data. The key thing about a paper is that you want to have the paper such that somebody else could reproduce that science. Okay, so there's a big deal about just what to include in supporting information so that people are able to reproduce the science that you're describing. All right, cover letter. The cover letter should contain the title and type of manuscript that you're submitting on behalf of all authors. And then the key thing is that you want to tell the editor, what's in this paper? Why is that important for publishing in that journal? Okay, so the primary objective of the cover letter is to inform the editor of your major findings and to highlight the relevance of the manuscript to the journal's readership. Okay, you'd be amazed at how many cover letters don't have anything about that in there, or they might just repeat the abstract. So I think in the end, these are key points. The review process, okay, I love this figure. I don't remember where this first appeared, but basically it talks about what happens to your paper after it's submitted. Okay, so papers that do not meet submission criteria, poorly composed papers or whatever, will be returned after editorial review. Okay, whatever. Especially if you submit to a high impact journal, it might decide that the paper just isn't of high enough impact based on what the editors are they think is important. Okay, and then of course it goes to reviewers, and they have to kind of go through and provide their opinions about the thing. And ultimately, the editorial decision about whether to publish is based on the reviewer comments and the editor's own examination of the manuscript. So basically, you're throwing your paper down the gauntlet, and maybe it'll be accepted, but maybe not. All right, so I mentioned that we did this project where we got a bunch of ACS editors to write papers about the publications business. We actually did what's called a virtual issue, where we assembled all these papers together in this cited issue that's right here. Okay, there were 20 papers total. The authors, mostly written by Prashant, myself, Jillian Buriak, who used to be the editor-in-chief of Chemistry of Materials, and Paul Weiss, who's the editor-in-chief of ACS Nano. And so in the end, those were so this just shows a table of manuscript preparation tips that summarizes some of the things I just talked about. And here's the actual titles and citations of the individual papers. So as I say, there were many people that contributed to this project. And there's lots of different topics here. Should I reveal the history of my manuscript from rejection to acceptance? The impact factor discussion that we've talked about a little bit, graphical, how to make figures, things like that. That's some of the papers. And here's another list of papers. Okay, who should be the corresponding authors? What about the cover letter? Rejecting without review, the whys and the hows. It just goes on and on. Okay, and the last one here, why did you accept my paper? Okay, so in the end, again, little discussions about just things to think about in the process of getting papers published. Okay, so I want to, one other topic I wanted to raise a little bit had to do with things like ethical guidelines, and ultimately this will get us into discussions about ethical issues for publications. Okay, so it turns out if you look up and just type into Google ethical guidelines to publications of chemical research from ACS Pubs, you will come up with this document. Okay, and this document is is an ACS policy statement that in a sense everybody should be aware of in terms of writing papers and also being an editor. So for example, the first subtopic under this is ethical obligations of editors of scientific journals. Okay, so I actually admit as an editor, I actually read this over frequently just to make sure I was doing the right thing. Okay, so I don't know if people can read this, but anyways, it said for the editors, an editor should give unbiased consideration to all manuscripts offered for publication. Okay, so that's hello. There's a lot of issues involved in that. I mean, you get papers from anybody on anywhere. And there's always this question about, is there some sort of implicit bias that you might have when you look at that paper, having to do with where it came from or who wrote it or whatever. And so we always have to think about those things in terms of this. And then the other aspect, the editor should consider manuscripts submitted for publication with all reasonable speed. Okay, so there's always this thing about just how long does it take to publish a paper, how long is the review process, how long is it just sitting on the editor's desk because the editor, is for whatever reason is too busy to think about it. For ACS publications, actually, those numbers are all very good. Okay, in terms of compared with the rest of the industry. Okay, so typically nowadays most papers that are full-length papers can go from submission to publication in about 10 weeks or so. JPhys Chem was 9 weeks the last time I looked it up. And for letters type papers, it might be more like 6 weeks. So that's in the publication industry. Those are all extremely good numbers. Okay, if you want to publish in other journals, there's a lot of things that can make it a lot longer. Many of us have gone through the pain and suffering of submitting papers to Nature journals. And gosh, a year? That's not unusual. And you rewrite the paper several times and all this kind of stuff. And the other aspect, I once had a paper that was accepted in a Nature journal like in August of a given year, but they didn't publish it until the following January. Okay, and turns out, remember this thing about the impact factor and how papers published at the end of a year only contribute 1 year to the impact factor. But if they're published in January, meaning like a week later, okay, then they get 2 years to contribute to the impact factor. And so, hey, hello, maybe that's a way of raising your impact factor just by timing the publication right. Funny thing about that. Okay, so anyways, so that just things to be aware of. And then down here, Ethical obligations of authors. Okay, in some respects, it's just the obvious things. An author's central obligation is to present accurate and complete account of the research performed, avoiding deception, including data collected or used, and an objective discussion of their significance. This kind of things that you would expect, if you want to say. Okay, so there's a lot of different issues. I won't go through all of them. There was something that came up in the last few years that was important, had to do with plagiarism. Okay, so it turns out the ACS journals, and most journals actually, adhere to the National Science Foundation definition of plagiarism. Okay, so I think in some respects, plagiarism where you're copying something out of somebody else's paper and just presenting it as if it's yourself, I think everybody understands that concept. Something that became more of a bigger issue in the last 10 years, that you shouldn't engage in self-plagiarism. Okay, so this is where you're just copying something out of one of your previous papers, okay, and presenting it. Okay, so there's always this thing about what do you mean by self-plagiarism, but here it's defined and what's acceptable and what's non-acceptable, things like that. And so in the end, I think that's just something to be aware of that comes up. And there are some ethical obligations of reviewers of manuscripts as well in this document, but I won't talk about it. All right, so in the last 10 years, something that has come up is this fact that most manuscripts now submitted to ACS publications or submitted to other publishers are run through a computer program that's called Crosscheck. Okay, and what that does is it compares the text in your manuscript to essentially all the scientific literature and seeing whether or not it copies what's elsewhere in the literature. So when you do a cross-check analysis on a paper, you'll get something that looks like this, okay? And what you see here is that every so often you'll see that it highlights, say, a sentence, and everywhere in this sentence which is highlighted is where that sentence, the highlighted portions of that sentence have occurred previously in the literature, and here it gives us number 21. As an editor, you can look up and see what paper 21 is. And what you see here is that it doesn't exactly match the sentence. There's a few terms that are not highlighted, but you can see it mostly does, okay? And so, you might say, oh my gosh, this person must have been looking at that sentence when they, in some previous paper when they wrote this down. Okay, well, not necessarily, okay? We always know this discussion about monkeys typing at typewriters, and they may accidentally type the works of Shakespeare by accident. So that happens, okay? I mean, you can't believe how often it happens, actually, especially in the scientific area where there's certain concepts which are really just communicated best in one way of wording things. So here, you notice paper 21 it got listed here, but it doesn't get listed elsewhere in the analysis, so it's probably just by accident. But here, and you see though paper 7 and paper 4 is more often. So what an editor has to do is to, when they see these kind of overlaps, you have to go and look up paper 4 and paper 7 and decide, okay, well, was this really copied out of that paper or not? Okay, so it's it is an issue. If the overlap is too high, the editor might reject the paper. If the overlap is not so high but still looks annoying, okay, then the editor might go back to the author and say, oh, you need to rewrite some sections of your paper because it looks like it's just taken out of some previous paper that you guys wrote. Now, in the materials and methods section of the paper, a lot of times there's just some precise wording that you need to use to describe something, and you're just going to repeat that in many papers. And so the editors, at least the ones that I know of, are smart enough to realize that's what you need to do. So in the end, the cross-check thing is applied selectively. All right. All right. So what I'm showing you here is it has to do with copyright information. There's something called the ACS Journal Publishing Agreement. If your paper is accepted in a journal, then you have to have gone through this process where you're basically telling the journal, what do you want to do about copyright? Okay, and what I'm showing you here is some excerpts from Form A, okay, and this is where the author transfers the copyright to the publisher. Okay, so that's the most common situation, at least right now, is where you submit your journal or your paper. After it's accepted, you sign this document, or it might even happen before it's accepted. You sign the document in which you're transferring your copyright to the publisher. The nice thing about that is that the publisher will publish your paper without charges. But of course, the bad thing about it is that that means that the paper will be hidden behind a paywall. Basically, you have to have a subscription to ACS Journals or whatever publisher it is in order to be able to see that paper. Okay, so there's another version of it in which you can have your paper published open access, but with pretty much most publications, there's a price to be paid for that process. Okay, so that's become a big deal over the course of the last few years. I'm not going to go into the pros and cons of which direction should one go into, but nevertheless, it is a piece of the story. And here I'm just showing you, the document that you sign. Okay, that's if you're the corresponding author of the paper, that basically transfers the copyright to in this example, the ACS. Okay, and actually there's a different copyright statement that has to do with supporting information, but it's important to realize that your supporting information is also part of the copyright document. Okay, and then this goes into later in the same document. It's a long document. It talks about things like reuse of the republication in like a thesis, a PhD thesis, okay, which normally is allowed. Actually, there's usually not an issue with that, but there is some fine print, so that's where the fine print comes in. The reuse of figures, tables, and artwork in future works. There you have to be a little more careful, okay, and it talks about here the text extracts up to 400 words can be used, and then the figures, there's some rules about figures that you should be aware of, things like that. It talks about using the material for teaching, which is normally not a problem at all. Presentation at conferences, normally not a problem, but be careful if you are talking about unpublished work and your presentation is recorded, okay? Because in a sense, if it's recorded and that recording is made available to anyone, then you've published it in that conference. So you have to be very careful about that. And then there's this issue about, can you share it with colleagues? Well, yeah, sure, that's not really an issue. And then can you put submitted works on websites and repositories? And the answer generally is yes, like the archive or Chem Archive or whatever. That nowadays is widely accepted. But then on the other hand, posting accepted and published manuscripts on websites is trickier, and you need to look over this information. And in particular, one thing that's come up over the last 10 years is that there are organizations that want you to upload their papers to those organizations that are copyrighted information, okay? And you have to be careful about what that means, okay? So there's this organization called Sci-Hub. Sci-Hub is an illegitimate website that basically wants you to upload all of your publications to it, and then it will make them available to anybody. Okay, so anyways, that's a problem. There's ResearchGate. ResearchGate is one that when they first started, they actually were doing the same thing, basically making papers available to anybody. But now it turns out there's some rules. The publishers got ganged up against ResearchGate, and now they have ResearchGate has rules about whether anybody can download papers that are stored away in ResearchGate. But anyways, just to be aware, this is an interesting field to navigate. Okay, so I'm almost done. I'm just showing you here every journal has one of these things. In this case, is for JPhys Chem, the guide to authors. So this goes through and defines, for example, the journal scope, okay, at the very beginning, okay? And so this is something to be aware of when you submit to a journal. What do they think their scope is? And you have to be in this scope or else you're gonna be in trouble. And then the other thing, this is when you submit your papers, they're usually going to ask you some questions about, for example, here it says, has this manuscript in whole or in part been submitted or previously considered by this journal? Okay, so So an example of something that some people do is your paper gets rejected by a journal, and then I'll just resubmit the same paper to the same journal and just hope that maybe some different editors will look at it and will change their opinion. Okay, well, it turns out if you do that, you can click yes and then you're fine. Okay, but if you click no, then that's an ethical violation and you have to accept the consequences of doing that. Okay, and then just talking about ethical violations, just to be aware, it is the case that sometimes papers get retracted, and there can be various reasons why papers might be retracted. This is a famous example, which is now probably would never happen again. But it turns out there was a paper that was published by Ron Breslow, who used to be the president of the ACS, among other things, famous professor. It turns out that he published a paper in JACS that largely reproduced his results from an earlier publication, and this goes into some of the details. Well, it turns out, that became an embarrassment. That was an example of self-plagiarism. And there's this organization called Retraction Watch that's looking for dirt, basically, about publications. And so they start, talking about this, and actually many other papers like Nature types decide they love to publish about dirt in other publishers. And so it became a major thing. So JACS ultimately retracted the paper, which, was actually, it wouldn't happen nowadays. There's a whole bunch of new criteria that came around about when you retract papers, and that wouldn't happen nowadays. Anyways, that's an example. And then, of course, the more serious problem is this one, this retraction, also from JACS, okay, in which a paper was just based on fraudulent data. And so this was, where, again, Retraction Watch loves these things and is just trying to look up all the nasty stuff. This doesn't really happen. This sort of thing doesn't happen very often. With JFIS-Chem, it happened usually about once a year. And so out of 6,000 papers, that's not very many. But in any event, we have to realize that there's all sorts of issues about, fabricating data, reproducing other people's data, things like that, that will lead to retractions. And ultimately, that's something that is a big problem in terms of things to think about. Okay, so that's it. Thank you very much. It's been a pleasure to have a chance to talk about the publications business. And I guess I could now start answering questions. Happy to do that.
All right, George. Thank you very much for that sort of soup to nuts view of the publication process. That was really interesting. I actually learned several things myself from that talk, so I'm sure that others did as well.
Again, as an editor, you just get reinforced on all these things all the time. So ultimately, for me, it was just part of stuff that I had to deal with all the time. But nevertheless, for the average person, it's like digging into all the details on the publications business. So, yeah.
Right. Well, we have some opportunity now, some time for a discussion and for questions. So as I was saying at the beginning, if you use the chat function, you can type your question in there. You can aim it at Robert Higgins or myself, Eric Shelter, and we can read your questions, or we can unmute you or ask you to unmute, and you can read them yourselves. So if anyone has any questions, now's your time to go ahead and do that. There were a couple of, or an item or two that popped up during the course of the talk, George. So maybe I'll just speak to that real fast while people are typing their other questions into the chat. So Judith Carano from here at Penn. Judith, do you want to comment on or do you want to make your comment to George and have him respond to it, or I can do it?
It was more just a general comment on impact factors, which I personally view with great suspicion, especially because they're used as a universal metric when in fact they differ greatly from field to field depending on people's work habits, collaboration habits, and habits of frequency of publication. So they were just general comments.
Oh, sure. Yeah, it's very much dependent on the subdiscipline. It's also dependent on just kind of the size of the enterprise, and also where the papers are published. Okay, in other words, there are some parts of the world where people are better at citing papers than for other parts of the world. For example, it turns out that the Chinese are better at citing each other's papers than are people in this country at citing each other's papers. And so a consequence is that we've gone through the calculations. You can ask the question, if I just consider the citations papers from China and then citations to other papers from China, and what are the total number of citations per paper that come out of that, and then compare that with citations of papers from the U.S. Citing papers from the U.S. And the Chinese are, on average, would generate papers with an impact factor that's about a point higher, okay, than the Americans, okay. And so it just has to do with issues of just how people are used to writing papers. And then the other thing is that you're right. I mean, another issue that we discovered was that there are some topics, subdisciplines, where the research is only done, say, in the U.S. And not, for example, in China. And so it turns out that that usually means that there's kind of a smaller number of people who are doing that research in that area than in others. Okay, other areas which are very active in China, then those are going to generate a lot more citations. So the nano field was kind of the darling of the citation industry for quite a long time, and that generated a lot of citations because, in a sense, there was a lot of activity worldwide in that, and especially in China. And then there's other fields, like an area that I know about is gas phase chemical physics, and it turns out that that's something which is kind of a much smaller field. It's mostly represented in the U.S. and Europe, and it turns out that's much lower citations. Therefore, those journals that specialize in that topic have much lower impact factors. Right? Yeah, and the publication industry is largely clueless as to how to deal with that. Okay, it's rather sad situation that I mean, the impact factor has been around for 45 years now, and yet it's amazing that understanding of the meaning of the impact factor is just such a qualitative topic. So yeah.
Thank you, Judith, for the comment. Others? Robert, do you have others?
So Jonathan Sessler wrote kind of an interesting little tidbit in the chat. So I'm going to unmute Jonathan, and then depending on what Jonathan has to say, maybe unmute Fraser Stoddart after that. So Jonathan, you should be unmuted now.
Okay, that means I have to wake up. Thank you, George. As Eric said, that was very informative. Quick point before I get to the main point is the ACS has its ethics, and the RSC and a number of other journals subscribes to the COPE, which is the Committee on Publishing Ethics.
Yes.
And you can learn a lot from looking at those.
Yeah,
I'm just telling the not apocryphal, inspirational story. So two of my heroes that aren't on this Zoom call, Jean-Marie Lane, and then what I wrote in this note, Jean-Pierre Sauvage. And I said, Fraser can tell the story better, but Jean-Pierre Sauvage's first cat name paper was published in Tetrahedron Letters, not a canonical high impact journal, yet decades later ended up having him share in the 2016 fun in Stockholm with Fraser and Ben Feringa. And so the key point is good science is good science, and we have to believe that it will get recognized. So you publish a high impact journal, you're borrowing the luster of other scientists. If you publish your own work and it's truly transformative, it will change the world. The kinetics might be slower, but the thermodynamics, we have to believe in those, that good science is good science. Otherwise, we should just go home. Well, we are at home. Okay, that's it for me.
Yeah, a very good comment. And in fact, actually, my highest cited paper was published in JPhys Chem B. Okay, and it didn't get a lot of citations in the first few years, but it now has nearly 10,000 citations. So it's, yeah, absolutely.
I see Fraser is on the call too. Do you want to add anything to that anecdote? Thumbs up. Yep, that's a very well point. Very well taken, Jonathan.
Yeah. I can speak, but what about this muting? Can you hear me?
Yeah, we can hear you now, sir.
Oh, okay. All right. Well, I would just add to what Jonathan said, because it has a good cutting edge to it. It wasn't only in tetrahedron letters that Jean-Pierre Sauvage published. He published in French. And that was a follow-up from his mentor, who also got a Nobel Prize, Jean-Marie Lane. So their first descriptions of
Cryptans.
cryptans and cryptates, if I recall rightly, was in 1968 or 69, also published back-to-back in tetrahedron letters in French. And so if you speak to Jean-Marie Lane, he will say, it doesn't matter a damn where you publish, if the science is good. And I'm just, of course, reiterating what Jonathan said, it will be recognized. The other thing I would say is that many of the national societies, and particularly I know the Royal Society in London now, are actually asking, when nominations are made, to have absolutely no metrics at all. And then I can tell you that it always comes up when I'm at meetings with other Nobel laureates. I have still to meet a Nobel laureate that has anything positive to say about H indices or impact factors. Everybody seems to be of one mind that it is a distraction and a bit of a waste of our time.
Absolutely, yes. Well said, well said.
I think those are excellent points. Of course, for the people just starting out, they're feeling these things the most acutely around impact factors and the pressure to get their work into the so-called highest impact journals. So these are the people I think that we all need to be thinking about when we're reviewing, we're making evaluations, and we're trying to contribute to this process in a sort of supportive way.
Can I jump in? This is Jonathan again. So there is a value to chasing a high impact publication in that it helps us bring up our game. But we must focus on using that sword edge to cut, slice, dice our story so it's buffed and polished to the finest sheen, most appealing. And so if we take this negative and turn it into an inspiration, then we're not beating the system, but we're using it in a positive way. So that means going back to the lab, doing a couple more experiments, or pulling on some loose thread because we think we can get this into a better journal, then that's a positive.
So I agree with Jonathan now on this particular point. I think it acts as an incentive to the young graduate students and postdocs. They are very much, particularly if they come from China, tuned into impact factors. And there is nothing that drives them more towards making sure that they have all their experimental data, all the calculations that might have been done under their belt, and then, okay, we're going to go for nature or science or a nature baby or whatever. So yes, I see that a lot, and that is the positive side to it. So yeah, we can tell these stories, which both Jonathan and I have done, in relation to the history of it. But remember, it was the late 1960s, and we're now living in the, well, it's difficult to know, second or third decade of the 21st century.
This is a lot of really good discussion. I think, unfortunately, we'll move on to our next speaker. So thank you again, George, so much. The other thing I just wanted to say, something that occurred to me from your talk, George, as you were talking about these virtual issues, which are compilations of papers from across a set of journals, for example, on one particular topic. I think that there's an opportunity there if there are students and postdocs within the center that identify a grouping of papers, that we could take that forward to the journals and propose a virtual issue on a topic related to science that's being done within CSSM. So maybe we can bear that in mind as we're thinking about things through the course of this workshop this week. And it would be great if a group of students and postdocs got organized and came together with a set of papers that we could take forward to the journals to try and promote a virtual issue.
Yeah, that's an excellent suggestion. Actually, I was involved in another CCI center that's now over with previously, and we did something very much along with that. So I even have an example then of that sort of thing.
All right, awesome. Let's keep that in mind. Okay, with that, I think we'll move on next